Today we're going to be going over k-nearest neighbors. K-nearest neighbors, or often called KNN, is a pattern recognition algorithm. So it's a pattern recognition. Algorithm for classification. So what this means is that if we get a new data point based on our older data or the data we've already collected, we can classify a particular point. So let's give an example. Let's just create a graph. So this is kind of like the y, and this is x. If we had a bunch of points, let's say these are all classified as A's. Let's say there's another A over here. Then there's a bunch of O's over here. If we got a new point, let's call it C over here, and we had K equal to 3, so K is actually the number of neighbors that we're trying to find, we'd probably say that this one, let's go back actually, let's change colors. We'd probably say that these three are probably the closest neighbors. So now that we have the closest neighbors, so this one's an A, these are all A's over here, and these are all O's. The three closest neighbors will decide what this new point C will be. So in this case there are two O's and there's one A. So we're going to classify C is an O. So you can imagine that this could be, A's could be a symbol for benign tumors, and O's can be symbols for malignant tumors. So in this case we would classify this new tumor C as malignant. So yeah, so now that we have an idea of what k-nearest neighbors is, how are we actually going to find the distance between these 2 points? So the way we're going to find the distance is using Euclidean distance. And the reason I'm going to show this one is because it's the simplest in my opinion, and also typically gets good results. So at a kind of the mathematical formula for Euclidean distance is sigma, so n I equals 0, actually let's say I equals 1, and we have qi pi squared. So this is probably the formula that you learned in high school at some point. So let's just kind of give a more concrete example. Let's say we had this graph over here. So we have y and we have x, and we have some point over here. Let's say 1, 3, 1, 2, 3, and some other point So let's call this Q, and then let's have some other point P be up here. We could find the distance between these 2 points by doing the same thing that's in the formula. So this D, just call it D. It's going to be 2 minus 1 squared plus 5 minus 3 squared. So in this case, it's going to just be 1 plus 4, so great, squared, so it's just root 5. So that's how we're going to find the distance. So if we had something over here, and over here, and over here, we would, and let's just say another thing right here, and let's say that this was the point that we were trying to classify right here. Like let's say that this was the point that we were trying to classify. We would find the distance between each of these points, and it looks like it's going to be like probably, I don't know, maybe these 3 points that are going to be the closest. So I'm just kind of eyeballing it, but we could, in theory, kind of have a calculation for each one of these. And then based on what these are, we would classify this new point right here. So what are some drawbacks of KNN? It's not really efficient with skewed data, and it's not algorithmically super fast. So in the next video, I'm going to try to show how to actually implement KNN with Python. So you'll actually get to see how fast this thing runs.